G'day ladies and gentlemen, it is the Raging Ranga here, and welcome to a quick recap of simultaneous linear equations. So linear functions and solving equations simultaneously. So skipping over this gear, straight into the good stuff. Alright, linear functions is basically any equation or function that creates a straight line. So there is a linear relationship between some value y, some value x. Here with this example, have a read of this here. I'm not going to read it for you. You're big boys and girls, now you can read it. Fantastic. So what we do is we can then graph the number of rides people have gone on versus the total cost. And this guy shouldn't have eaten that hot dog before going on the roller coaster. What a scrub, man. Anyway, so remember the initial cost here is our y-intercept, so our c value. Bear with me. Hey, there we go. That's our c value in an equation y equals mx plus c. That would be our c value. And then each time x goes up 1, y goes up 6. So 6 would be our m value here. So the equation for this line, which represents the total cost against the number of rides, is going to be y, or the total cost equals 6x plus 10, okay? Another way we can write this if we're talking in terms of functions, and we'll probably talk about this more later on, is f of x. F of x equals 6x plus 10. Some function which involves this variable x is 6x plus 10. We're basically swapping out the y for this thing here, f of x. And how that then works is I can put a certain value for x in there. So say f of 5 would then equal 6 times our x value, which is 5, plus 10. You do the math and you should get 40. So if we go on 5 rides, it's going to cost $40 all up. Okay, bam, done. Gradient and y-intercept we just talked about there. Gradient is your y step over your x step. Y step, how far you gone in the y, over how far you go in the x. Okay, if we got 2 points, y1, x1, y1, and a point x2, y2, the slope between those two points, or the line that connects to those 2 points, its slope will be the y value of the y value of the second one, take the y value of the first one, we call that y step, divided by the x value of the second point, take the x value of the first point, or the y step. So that there is also referred to as m. Okay, easy done. Y-intercept is just wherever the line cuts the y-axis. It's not where it cuts the x-axis. Okay, if it cuts the x-axis, that's down here somewhere. Okay, we're interested in where it cuts the y-axis, where it cuts the vertical axis. Okay, because again, the subject of this equation is y. We're interested in all the things to do with y. So all the things to do with y is that we need m lots of x plus whatever y starts at. So whatever y starts at is c, or the y-intercept. Okay, so like we've said here, write this down. There's your first definition. The equation of the line with gradient m and y-intercept c is y equals mx plus c. Write that down. Know it, love it, live it. Linear is love, linear is life. Okay, draw this down afterwards. Okay, draw this down after you've written this down. So anything in green we typically draw down, so do that. Do it, come on, write it down. What are you waiting for? Okay, with that in mind, give these questions here a go. And we're going to jump on to the next section now. Okay, so the next concept here is graphing lines from equations. Graphing lines from equations. Turns out y equals mx plus c is not the only way to write down a linear equation. Okay, there's also what we call the general form. ax plus by equals c. Each of these equations here tells us something different. Okay, each of these equations will tell us something different. Now, this is great stuff to do here. Write down this and draw the graph next to it. We've already done this, but write it down again for comparison to general form. So we saw gradient intercept form before in the last question. If you're given an equation, y equals mx plus c, say I give you something like y equals 3 halves x plus 17. So I give you that. Can you draw a graph using that? Absolutely you can. Again, this here is the gradient. This here, this here is the y-intercept. You draw your basic graph first, like that. Start with your y-intercept, mark that in there, 17, so that would be 17, and then you can start drawing the slope in from there. Well, if this is our slope here, that means that every time x goes up 2, remember that's x step, y goes up 3. So go across 2 in the x, up 3 in the y. And write down whatever that point would be, draw the graph from that. And that's how you draw a graph using y-intercept form. Out of interest, that point there would be in the x, that would be 2, because we've been at 0. We started at 0 in the x here, and we went across 2, so we're now at 2. We started at 17 in the y, went up 3, so we're now at 20. And does that make sense? If I put a 2 into this equation here, what do I get for y? So it'd be 3 halves times 2, which equals 3, plus 17 gives you 20. So this graph does in fact represent this equation here. So what about general form? General form, where we've got x and y on the left hand side equaling some constant c. Let's have a look at that. So in that case, that could be something like 3x take 5y equals 10, for example. Could be that. Who knows? How could we draw a graph using that? Well, you follow this method here. So you write down these methods so you know how to draw graphs using either slope-intercept or gradient-intercept form, this one here, or using general form like this here. So the method for drawing a graph using general form is pretty easy actually. All you do is you're finding the y-intercept point and the x-intercept point. They are key points because we know the x value at the y-intercept, we know the y value at the x-intercept. Have a think about what they are at those points. I can wait. I'm a video. I'm a video. Hey, look at me. I'm a video. Can't you see? Yeah, I'm a video. I'm a video. Okay. If you said that x is 0 at the y-intercept and y is 0 at the x-intercept, you'd be absolutely right. So all we do is we plug in 0 for x into this equation here, in our general equation, and find what y is, and that will give you the y-intercept. 0 and some y value. And over at the x-intercept, you just do the opposite. You make y equals 0, and you find out what x is from that. So, for example, some x value and 0 for y. Here's an example of that here, of both of them. You should be familiar with how to do the the intercept gradient form now. Let's look at how to draw a graph for a general equation. So we've got 2x take 4y equals 12. Well, we set x to equal 0. That gets rid of this whole thing here. Whoop, not the whole thing there. Gets rid of that bit there. You're left with negative 4y equals 12, so y will equal negative 3, which is this point here, 0 and negative 3. We've got 1 point marked in. We just do the opposite to get the x-intercept point. So instead of getting rid of the x value, we set y to equal 0. That gets rid of this whole term. We're left with 2x equals 12. That means x must equal 6 when y equals 0. That gets us to that point there. Then all we need to do, once we mark those points in, draw a line through both points. And that is, ladies and gentlemen, that. You can also draw graphs using your graphics calculator. But if you want to draw graphs using your graphics calculator, you first have to get it into intercept form, intercept gradient form. You can't have it in general form. So to show you how to use your calculator, here's a calculator I prepared earlier. We're going to do this question down here using the calculator. So I'm using a Casio. You might have a TI, heaven forbid, but the process should be similar for both. On the Casio, we want to go down to graph, and TI should be similar to that. You select your graphing function, and here we got all the different graphs we can make. So we're just going to go with y1, and it's basically y equals. y1 just means y equals. So we start typing in the equation after that. Problem is our equation here is in the form 3x plus 2y equals 12. We want it in the form y equals something. So we're going to have to do a little bit of rearranging. First things first, let's move that 3x over the other side. If we want to get rid of 3x on this side, we'll need to take 3x from both sides, so we're left with that. Okay, we get rid of 3x by taking it on the other side. We've still got 2y equals 12 take 3x. We need to get rid of the 2. We need to get rid of the 2 times. To get rid of the 2 times, we divide everything by 2. So we divide the 2y by 2 first. We're left with y. We divide the 12 by 2. We get 6. We divide the negative 3x by 2. And we get negative 3 halves x. Okay, negative 3 halves x. Dividing by 2 doesn't really affect the x. It just affects this number out the front of the x. So now we can put it into our calculator as 6 take 3 halves x. And then we press EXE and then graph on the Casio or the equivalent on the TI. And there's your graph right there. Easy peasy. And that's all there is to it, ladies and gentlemen. That's your brief introduction, first of all, to linear equations. Next time, we'll take a look at simultaneous linear equations. Until then, this is Raging Ranga, signing off.